welcome. My name's James. I'm a product designer and I'm finally doing it. We are finally doing some design streams. So today I'm going to start a new project, which is something I've been wanting to do for a long time. And it is a project that I'm doing with some friends, some ex-colleagues, and it's a music tech project. So I'm very excited about it. This is, this is my thing. This is what I'm into. Love music, love making music, and I love making tools for making music, and I love designing things. So this is all of those things combined. So I'm very excited about it. And hopefully this continues and we get some more content out of it as well. But even if we don't, doesn't bother me because I just love doing this. Hey Elk, thanks for joining in. You finally get to see what's going on here. So basically this stream I'm going to be doing some CAD design. Now normally when you start a design project you don't start with CAD, but I can't exactly show all of the background for this project yet. Hopefully coming up in the future we'll have I might do a stream at least with Yessa, who is sort of the Kickstarter of this project. It's his baby. So at least I'll try and get him and maybe the other guys that are involved to join in, and we can do a bit of an introduction and talk about who's responsible for what. But from my side, I'm just doing mostly mechanical design as well as some UX type stuff. So on the stream today, I'm just going to do some mechanical stuff just to get into it. And then hopefully, we can bring in Yessa and the other guys and we can give a bit more background. But I don't want to give away too much of the secret sauce of the ideas that we have for what's going to make this product unique. But I can give a little bit of background at least. So I'm going to show you something here, which is just a little bit of a inspiration page. It would be awesome to hear from Yessa as well. I'm very excited to watch the project unfold. Yeah, and Yessa is excited too. He's all for the streaming stuff, and I think he's pretty keen to get involved in streaming when it's possible for him. But he's also likes the idea of having, opening up the design and letting people see what we're working on, and hopefully getting a bit more interest in it as well. So what you're looking at right here is for, I guess you can say, inspiration products. Now we're not trying to make something like any of these in particular. You can just consider them as inspiration. So yeah, we're not making a keyboard synth, or we're not making a looper like this, or a drum machine like this, or a playable drum pad like this, but we're inspired by elements of all of these products. Now the goal of what is currently called LDM, standing for live drum machine, is that it in essence should be a drum machine which is playable in a way that's like how you play an instrument. So like when somebody plays an instrument like a guitar or drums or something, once you're comfortable enough on that instrument, you can get into a flow state. You can go on autopilot and you can let flow through you the ideas that you have, and it comes out as music. It's not so much thinking, but rather just doing it. And the instrument becomes an extension of your real-time creativity. So drum machines traditionally are a little bit disconnected from that. They're quite cognitively complicated to operate a lot of the time, and it means there's a lot more thinking and planning and programming and stuff than there is just like feeling the beat or feeling the rhythm and expressing it. So yeah, MIDI or CV or both. I'll get into that more. um, the machine itself should actually work standalone. Likely, it will have MIDI in and MIDI out, but it is a standalone device. So it will create its own audio, and you will create that audio in the device, and it will output audio. Um, yes. So there's a lot of questions. There's a lot of unknowns. We don't want it to be too restricted now in exactly how it should operate. We don't know if it should have some playable elements like this Nord Drum 3 where you have actual pads that you can play with sticks. But this is something in the direction of, something that looks a little bit more like an instrument to play. And that's another element, is that it shouldn't only feel to you as the musician that it is like an instrument, but it should also look like that to an audience. Because that's the other thing with these machines and people using computers in their live set and using hardware devices in their live set, is sometimes it creates a bit of a disconnect between the performer and the audience, because the performer can be really focused on the equipment, and a lot of the time for the user who's not familiar with the equipment, they find it hard to understand what the performer is actually doing. You see people pressing buttons, but it's not exactly clear what the buttons are doing, and you don't really see a direct correlation between the movements of the artist and the sound that you're hearing. I was thinking more about hooking into a modular setup as well as MIDI, not a necessary thing. Was more curious than anything. Yeah, so I'm sure that there will be ways to link this in with a modular setup, and there will be audio ins or at least audio outs, possibly audio ins, possibly MIDI in and out, but nothing is 100% now. It's all sort of it's a lot of these decisions are being made in parallel to what I'm about to start doing here, which is the mechanical design. Now, that seems kind of ridiculous. It seems like, well, shouldn't you know exactly what it's doing and how many buttons it needs and everything before you start making it? And yes, in most cases, that's true. So generally, the design process goes like you do some research, you find what the opportunity is, you try to identify who your target market is, who your target user is, what are their needs, what are their desires, what are the use cases they want to use the product in, and then start conceptualizing things. So making concept sketches of all different kinds of things that could fit those needs, that could fit those use cases, and could create a desirable experience for that specific user. All of this stuff is happening. So you don't need to worry about that I'm skipping any steps. And a lot of this stuff has already happened. I've been meeting with Yessa for the last few weeks, and we've been having sessions on this at his place while we're also talking in a group on Discord. So this stuff isn't being skipped. It's just a little bit of the secret sauce, I guess, that we don't want to spill everything here now. And it's also still sort of progressing, so can't tell you exactly what decisions are being made yet, and I can't also guarantee that any decisions we're making now will be true in a few months' time. 100% agree. I jam a lot, but it's pretty boring to watch. I don't find synth performances overly entertaining to watch. Yeah, I mean I think that's common. Unless it's you're somebody who's familiar with the equipment and the process, then it's a lot more interesting. But generally, for the average viewer, watching somebody play a keyboard or a piano or a drum kit or something is more. It seems more tangible. It's easy to understand what is happening. Man, this is exciting for you guys. Yeah, I'm excited about it too. So, as I said, this stuff is happening in parallel, and it's already been happening. where we've also been doing design sketching, concept sketching, but all of this stuff, it's not that easy to live stream for one, and we also don't want to, yeah, we don't want to give everything away. So what you'll see in this stream is me doing some mechanical design, and I'll be doing mechanical design in SolidWorks, which I have here. This is SolidWorks for Makers, or SolidWorks Connected, which is something new I'm trying out. I haven't tried out this service before, but it's a very professional CAD software that you can get as a maker for $10 per month, which is a really good deal. There are alternatives out there, like, you know, a lot of people use Fusion 360 or even Google SketchUp or other programs like that because they offer free alternatives. But in my profession, well, I've been trained to use SolidWorks, and I find SolidWorks is very capable, and it has some things that I've found are missing from Fusion 360, and that's why I'm going to go ahead with using SolidWorks. So, apologies if if you're a CAD user, a CAD person out there who's wanting to follow along and you're not used to SolidWorks, but this is the way it's going to be. And maybe in another video I'll explain why I prefer to use this over Fusion and what I think Fusion could add in order to be comparable. But yeah, SolidWorks for now. So I'm going to be doing parametric design in SolidWorks. And parametric design basically means like, I mean, I could give a graphical explanation, but I think I'll just briefly explain. Basically, you set everything up so that if you decide to make changes later, everything is linked in a way that once you can make a change very early in the process that will update everything up to its current form, if that makes sense. It's kind of like a spreadsheet. You can have a spreadsheet where you enter in one cell and you have a bunch of other cells which have equations that link them to that first cell. So if they're all linked by equations and then you update the first cell, all of these are going to be updated with new values because they're just referencing that original cell with some equations. The way that works in CAD is, you know, if you have a square and you define that this dimension is 10 millimeters and this dimension is 20 millimeters, then you design a bunch of stuff around that square. So you design a board with a hole in it that fits that shape, and then you design a peg or something which is that shape. If you link the size of that hole in the board to the original drawing, and you link the size of that wooden peg to the original drawing, then if later you decide actually that peg should have been 20 millimeters by 20 millimeters, so you go back to your original sketch, change the dimension, and everything gets updated. So the hole in the board is now 20 by 20, and the peg is now 20 by 20. I didn't have to individually do it to both. So that's a very simple explanation of what parametric modeling means, but it's a lot more in depth than that. But the reason why I'm explaining it now is to basically say that there is no harm in me setting up a device in CAD now, knowing that it's not going to be the final design. Because once I've set it up, there's a lot of work to do in creating a metal enclosure and in creating all the buttons and all the jacks and all the knobs and all those, and the display and everything. Once I've sort of built that out in CAD in a rough way, I still have complete flexibility to change it afterwards. So I can change the positions of things, I can change the number of buttons, I can change the size of buttons and everything. It's nothing set in stone now. But I can start working, and that's what I'm going to do. So know that what I'm doing here will likely change, and that's okay, because I'm going to set it all up so it's very easy to change when we do decide to make the changes. So I think that's enough intro. Been rambling for 17 minutes. Let's get into some CAD. Actually, if I quickly go back to show you this image here, some reasons why we are taking inspiration from these devices. One of them is to do with the size of the product. So this product here it's a small keyboard, this Novation base station. It's it's pretty chunky, but it's still small enough that you can fit it in a backpack. And this is kind of a rough goal that we're setting, that we don't necessarily want to limit the scope of the project to be that it has to fit in a backpack, but that's kind of a good starting point. So we want to allow for it to be as big as it needs to be. And if it can fit in a backpack, then that's very nice, because I think a lot of people would find a lot of convenience in transporting it in a backpack. If it needs to be bigger, it will be bigger. If it can be smaller, or if it doesn't need to be that big, then it'll be smaller. But this is kind of a rough place to start from. So that's kind of what I'm going to aim for in the CAD. We also know roughly that there are going to be, some output ports, probably like these 1/4-inch jacks, and there's probably going to be MIDI jacks, probably, and there will definitely be a power input, and probably also some USB-C or USB connection, whether that's USB-C or USB-B like this one. Not exactly sure yet, but we'll add provisions for making that decision. We also know there's probably going to be some number of knobs. How many, we don't know yet. There's probably going to be some buttons, maybe like these, or maybe more mechanical type of buttons, like mechanical keyboard switches. There might be a fader or two. There will likely be a screen, a display, and it'll probably be a fairly decent size. Maybe 7-inch is sort of the idea that we're thinking about now, but none of this is set in stone. So I'm going to try to set up the model to be roughly the size of a backpack fitting device, with some buttons, some knobs, a screen, and some ports on the back, and then we'll see how we go from there. Lots to do, so I'm sure this will keep me very busy for a while. And at the same time, faders and knobs would be good for mixing individual lanes on the device. Yeah, likely there will be some kind of mixing capabilities. And we're not exactly sure how many tracks there might be. Like, we're thinking maybe 8 or so at the moment. But so there could be 8 knobs, or we could have less, and maybe they have dual functionalities, or yeah. But mixing will likely be a part of it. I've just installed this version of SolidWorks yesterday. So it's very much stock standard as it comes installed, and I usually make some tweaks to the UI and the tools and everything. So you'll see me making some changes there, and also I'll explain why I make those changes. I rarely use a full 11-piece kit. 8 is pretty good amount. Yeah, I think 8 is a pretty good amount, and we might have a way to double that if you want to have 16 tracks on 2 pages or something, but we'll see. Okay, so first thing, I'm gonna make a part, and okay. Off to a good start, SolidWorks. It's just telling me that the part template is saved in the wrong place or something. but that's okay. So what I'm going to do is something. So we're in a parametric modeling software, and I'm going to do something which is called skeleton modeling. It's not like a company secret or anything. There's many companies using this, but it is a bit of kind of an industry secret in a way. Like, it's not often taught in university or online, but you'll find that a lot of people in industry are doing this because it makes things just much more flexible. And when you have a lot of parts, I imagine this product will have thousands of individual bodies at least, and probably at least 20 parts. That starts getting really complicated. So having everything linked to a skeleton model is ideal. This is analog drum machine or sample based. So not being analog doesn't necessarily mean sample based. I'll just say that. It will be a digital drum machine. Whether or not it's sample based or synthesized is not for me to decide. That'll be Yes's thing. Maybe a mix of both, or I'm not really 100% sure yet. But it is digital, I can tell you that. So a skeleton model basically means you have one part which has a bunch of sketches inside it, and those sketches are basically what holds all of the dimensions for everything in the product. So I'll have a top view which shows everything, like in the top view, all of the layout, exactly where everything will be placed from the top, the exact size of the body, the size of the PCBs, the size of the display and everything. And I'll show all of that stuff from the top and from the side and from the front. And that will all be very well defined in this skeleton model as sketches. So sketches from the top plane, the right plane, and the front plane. Now, every physical part that has 3D geometry, when I create that part, the first thing I'll do is insert the skeleton model. So I'll insert this part which just has sketches in it. And then all the 3D geometry I create will be linked to that skeleton model. So every single part will have a skeleton inside it, and that skeleton is the same skeleton that's shared in every single part. That way, when I change something in the skeleton, every single part will update to match those changes. So if I have a button and an enclosure, and the position of the button changes and the size of the button changes, I do that in the skeleton. The enclosure will update, so the hole will update, and the button will update. So that's why we do skeleton modeling. And you'll see me sort of sitting here at some points just thinking, because I have to decide where things should go in the skeleton, because the architecture is really important for making things clear and easier for me in the future. I guess I'm curious as to the sound engine. I use the OT2, Octatrack 2 with samples, but a synthesis-based machine would be killer. Digital or analog is irrelevant to me for synthesis, lol. Yeah, I mean, that's a good attitude to have. I think that for anyone, it should be irrelevant. I think digital's at a point now where it's, saying that it's different to analog when it's the same type of synthesis is, I mean, I'm not going to go too deep into that. That's a whole rabbit hole. That auto adjustment feature is really nice. I can't imagine having to go back and make manual adjustments to everything. Yeah. That's, I mean, it's not necessarily a feature, it's just a workflow. You can use SolidWorks without doing that, but this is the way I do it. And a lot of other people do it too. So what I generally do is I start from the top, and I'll make a general footprint. Now I don't like this shaded sketch contours, so I'm going to turn that off. It just makes enclosed areas shaded. And I'm going to usually make center lines, and what I like to do is make them not go the whole way through, but they have a point in the middle. I'm going to make vertical constraints here, and that way I can link this to the origin, and if I want to unlink it, I can unlink it like that very easily. I also get midpoint dots here, which can be nice for aligning things. So how big is a backpack? Because we need to fit this thing in a backpack. So let me grab a backpack and a tape measure. Let's go to the overhead. Oh, I don't know why this stopwatch is always here. Okay, got a backpack. I mean, realistically, fitting inside here, probably wouldn't want to go over 40 centimeters. Don't know if you can see that, it might be too bright. 40 centimeters is here. Sorry for the American viewers. Using the old British units, but I don't know what that correlates to in inches. So yeah, I mean maximum 40 I would say. What have we got in this direction? Let's say can probably get away with maybe 28. That's pretty big though. Maybe 26. And this isn't a huge backpack either. Yeah, maybe 38 by 26 could be like a maximum. 2.54 centimeters to an inch. Well, yeah, I know 30 centimeters is roughly 12 inches, so yeah, 36, I guess it's close to 14 inches or so. 15, I don't know. That's this backpack. Let me try another one. Another one here. This one's a bit longer. So this one could go to like 44. The width maybe, yeah, maybe 30 would fit, but I wouldn't go more than that. I'm gonna start out at 26 by 38, I think. All right, apologies for okay. So gonna make this what did I say, 38 centimeters, which is 380 millimeters. And what is happening here? 0.38 meters. Okay. Is this like not connected to the cloud or something? Okay. I think the technical issues are related to, I think you need to have this SolidWorks 3D Experience thing running in a browser to be connected. That part document error I had in the beginning, I think was related to that. So as much as this is going to sound really bad, I'm going to start again. But I actually really didn't do much, so it's going to be very quick to get it back. This is the dashboard, by the way. So yeah, with the SolidWorks thing, you get SolidWorks connected, Xdesign, Xshape, all of this stuff, and you unfortunately have to launch it from the web browser, which is a little bit annoying, but what can you do? All right, so now we have proper part document templates. And we're frozen. Connection stuff, I guess. Can we make a part? Thank you. Okay, so what I did before as well is I usually change this background to be plain white. I'm not into that shading. I just like it plain white. We go top view. Do the same thing that I did before. Get some center lines. When you double click, it stops drawing a line. I'm gonna make these horizontal. Connect this to the middle, and now my dimensions should hopefully be in millimeters. They are 380 millimeters by 260 millimeters. Okay, so now we've got a basic footprint on the top plane, and I'm going to name this footprint. I'm going to name it top footprint. That's another important thing, is to keep track of everything in your feature tree, which will be this list down the side, and make sure everything's named well. Sorry, I've been talking too much. And then I will do a sketch on the, not the top plane, but the front plane. And I can draw a rectangle, and I can link that oops, can link that directly to there, and this to here. And we're going to choose the height. Okay, so here's another little tip. When you right click and move the mouse, you have this little wheel, and by default it has 4 options, but I generally like to have it with 8 options, which you can do. Where can you do it? I think it's in customize, keyboard, mouse gestures. Yeah, so we've got 8 gestures, and I'm currently in a part, and I like it to normal to on this, and I generally put actually I'll do that in assembly as well, and sketch, Is that what I normally do? Yeah, I think so. And then I normally put measure here and here. This is just useful for measuring lengths of things when you're looking at a part. So now when I right click and drag to here, it will rotate the camera so that I'm normal to this plane that I'm sketching on. Now I need to decide, I can also dimension things by grabbing this top position. Need to decide how tall this is going to be, so I think for a starting point, maybe this seems too low, but I think I'm going to go 40 millimeters. Hopefully this product is going to have one PCB in it, or maybe two. But if there's two, I hope it's like one flat one and one like this, you know what I mean? And I'll explain why later, but sometimes it's nice to put jacks on a flat PCB. So 40 millimeters I think is enough, but it might even be able to be less. We'll see. So front. I'm actually just going to call this front reference and top reference. Sometimes I do like a separate top footprint from the top reference, and the reason why is if I want to have a product with a draft angle. I'll just open up Paint so I can explain some things. If I'm going to have a product with a draft angle, which means that the edges are angled like this, that's very over dramatized, but you do this with die cast aluminium enclosures and stuff so that it's easy to pull the mold off the top and the bottom. So the top mold can go this way and the bottom mold can go this way, and it's easy to pull off this angled surface. If I'm going to do that, I'll make a sketch which is the bottom footprint, which is where these points are going to meet. But then I might have a top dimension drawing which is based on this this width here, which is less than this width. So I want to position everything on this top face, you know, because this is where all the knobs and buttons and stuff are going to be. So the square which represents this top face is really my top reference. Like that's what everything has to fit in between. But the top footprint, which is the overall footprint of the device, is going to be this dimension. So yeah, on a product which is going to be die cast, that's how I would set it up. But because this is most likely going to be folded sheet metal, the edges are just going to be straight like this. So the top reference is also the top footprint. I don't have to account for this angle, so I'm not going to worry about that. Maybe I'll just leave this. So yeah, now I need to decide how I want to split this and where I want to put extra information, because sometimes loading up one sketch with too much information is too much, so I try to split it. So I think I'm just going to have like a very, very basic footprint from all four sides, and that's all that will be on the footprints, and then I'll go into more details about the enclosure in other sketches. I want to give a shout out to Martin from Wintergarten. He's you might have seen him on YouTube. There's a guy who has designed what he calls a marble machine, which is this big machine that plays music with marbles. And he does a lot of design, live streaming, stuff like this. And I can say without any question, that I'm definitely inspired by him, by his process. The at least you know, he's not a professional designer, but he's gotten really good at at his design stuff through the process of making these machines. But he's also really good at creating content about it and live streaming and stuff. So I've definitely taken some inspiration from him. But recently he posted some streams where he was trying to get into this whole parametric modeling stuff. And sometimes I want to like reach out to him and be like he's having trouble with something for ages, and I'm like, I have the answer, but you know, you don't want to tell people what to do, and he has thousands of people screaming at him from different angles, telling him different things to do. So he can decide how he wants to do things, and he can learn in his own time, you know. And I'm not saying that I'm better than him in any way. It's just for some particular things I feel like I have the answer. And yeah, recently he was doing a stream where he was like, okay, I understand this whole desire for parametric modeling and like linking things to sketches, but he kind of went like a little bit extreme into that, where it was like everything has to be on like one sketch or like two sketches. And I understand like the drive where he where he got this idea from, linking everything to sketches. But I think that that doesn't mean you need to link everything to like two sketches, because what he ended up doing was filling up those two sketches with a lot of data and a lot of information, and the sketches became too heavy and hard to work with, and also quite confusing to look at and to find where things are. So what I like to do is to layer sketches in levels of complexity. So the bottom level is like really basic, low level complexity. So I just have I just realized my my Rust map is coming up here. It's alright, I'll have to figure out how to turn that off later. Right, reference. Yeah, so I like setting things up layered in complexity. I always appreciate tips from people who know more than me. Yeah, me too. I think sometimes, I mean, for someone like Wintergarden, he's just getting tips from thousands of people, and it's hard to know. Like, he has no idea what my background is. If I just write a comment on YouTube or something, he might just think like, oh, it's just another person saying things to me. And there's also other professionals who would be saying the opposite thing to me, and that's also fine. So, but I'm sure if Martin and I were friends, and he knew things that I was working on and stuff, he maybe would maybe you would like to hear some tips. But I mean, I've also learned a lot of things from him, so it's not, you know, yeah, you get what I mean. So yeah, levels of complexity. So these sketches will not get any more information than this, but they will drive other sketches. So let's give an example. These are my just overall dimensions. Invite him to your streams. I mean, he's a busy guy, and he's also got thousands and thousands of viewers. I think it'll be a while before I end up on his radar, I think. So let me give an example. So if I go to the top view, I'm making a new sketch now. I'm going to turn off the front and the right references, so I just have the top reference. So I'm going to link things to this sketch. What I want to do is start looking at the sheet metal enclosure. So basically, if I think about how this sheet metal will be, this sheet metal enclosure will be, and it doesn't have to stay like this, but this is just my idea for now, and I've seen a lot of other companies doing designs like this. You basically have a flat aluminium top, and then a folded aluminium bottom. So it's flat, and then the edges fold up. So it's like this. It folds up, and then there's a flat top. These are folded corners, and you can have like metal standoffs that go like this through the body, and then screws that go in through the bottom into those. I need to find a better way to draw this. But yeah, so basically I'm going to have a folded bottom and a flat top. So to start the folded bottom, so I know that the bottom is going to be a big square, and the edges are going to be folded up. So from the top, I'm going to see the edge like this, which is going to be, it's going to have a material thickness, which I'm thinking right now is going to be 2 millimeters. Now, I'm also going to try to set this up in a way that everything will drive off this one dimension that I've made just here. And when I say everything, I mean all of the sheet metal dimensions. So if I make those equal, this one's 2 millimeters as well, then I'm gonna put the sides here. I'm not gonna make it a closed rectangle, I'm just gonna put lines, and I'm gonna put a dotted line in the middle for the thickness, so that I can set that to construction, as construction line, and I can make that equal to this one. So now this is also 2 millimeters thick. I'm going to do the same thing over here. This might seem overcomplicated to do this many lines, because you could just draw a rectangle and then do an offset. And I can't exactly explain why I do things in such a specific way, but it's come from God, I guess over 10 years of using this software that I've trained myself to do these things. And yeah, I find that if I set everything up like this in the beginning, everything gets much easier later. So this sketch now has the edges of my enclosure as 2 millimeter walls. I can close that, and I can call this like enclosure top. So what I was explaining before about the layers of complexity. So I have this driving top reference, which is the size of the box, and I have this this wall thickness drawing now, which if I turn off the original drawing, this is just a drawing which shows the thickness of the walls. And I mean, you can also infer the size of the plate from this. And this is linked to the top reference. Okay, but it's still sketches, so I'm still doing everything in the one sketch model. But if I decide to change the overall height to 200 millimeters, then my enclosure top drawing gets updated with it. This is what I was saying about the spreadsheet type links. So also, my front and my right references, because everything was linked to the top reference, if I adjust anything there, if I make this 300, my front reference also updated its width. So this is what I'm saying, this is the beauty of linking everything together, and going through layers of complexity, is that I can go back to the earliest layer, which was just the basic shape of the product, and I can change it, and it will trickle down and update all of the more complicated stuff that I did after that. Okay, so now I'm gonna look at the enclosure from the right. Oops. So I want to draw what the enclosure will look like from the right. Just going to draw it basically here, and then I'll constrain everything afterwards. Now here's an interesting trick. This might seem a little bit weird, but I'm going to make these into construction lines. And then I'm going to put arcs. I'm going to choose 3-point arcs. I'm going to put these in the corners. And something that other CAD users, SolidWorks users might say is like, you can just click the sketch fillet button and click on the corner and it'll fillet the corner. And you can, and I think there's even a way to show the point there which the corner actually correlates to, but sometimes these little features that make your life easier actually make your life harder. So I tend to manually draw everything in, and like I said before, you set it up once and it'll be, it just makes everything easier from that point onwards. So I made these 2 points vertical, which means that these will be concentric. I can even, they'll be concentric if these have the same dimensions, but I'll actually make them concentric, because then what that means is the thickness of this line will determine of these will determine the thickness of these, because these 2 circles are concentric. Might be going a bit fast now, but I guess this isn't meant to be like a all the basics tutorial. I'm trying to get this done. So if Elk, I know it's only you watching at the moment, but if you or if anybody watching this later has any questions, feel free to just ask what the hell is concentric mean. I'll try to explain it. But I mean, you've worked in lots of technical stuff, so you probably understand. Then I'm drawing new lines over these dotted lines, because then I can keep the dotted lines there. To attach to my other sketch. So let me just put these arcs in here. I'm just making them tangent to the, so I'm making this arc tangent to the construction line. Then I'll align the 2 starting points vertically and make them concentric. Then I can get my top reference, link this corner to this corner. Oops. Why didn't it link? Hello. Make those coincident. Make that coincident with that. Can add in my right reference, make that coincident there, and make that coincident there. Then show my enclosure top, where I can see this thickness from this angle. So if I click that point, make it concentric with this line, then the thickness of all of this is defined from my previous sketch, and all I have to do here is make this radius also equal to the thickness. And in sheet metal that's called a T1 bend, when the radius of the bend is the same as the thickness of the material. So if you could see, if I was going to put a dimension here, it's 2 millimeters, which is the same as the material thickness. And then I will make this internal radius equal to this internal radius. And now, if I hide every other sketch, you can see, how do I forgot how to hide dimensions. How to hide relations. Well, what I was going to say is, now that everything is black, all the lines are black, that means that they're fully defined. So nothing is without a dimension. The program knows exactly how big everything is, and there is no questions. There's nothing I can change now, because I've fully defined this sketch without putting a single dimension in there. All of the dimensions in that sketch are referencing the previous sketches I made. So like I showed before, when I change the width of the device, it will change the width of that sketch. But also, since I linked the thickness of these lines to this sketch, and these line thicknesses linked to this line, and that all only has one 2 millimeter dimension, if I change that to 4, this sketch updates as well. So everything is linked. If I change this to 8 millimeter thick metal, it changes this sketch, it changes this sketch. So this dimension I put here is my driving dimension. So all I need to do when I want to change the material thickness is go back and change that, and everything will be updated. I want to emphasize, this doesn't happen automatically with SolidWorks. This is you have to make these choices to set everything up this way from the beginning. And if you do it, if you're methodical about it, if you name everything, if you link everything, and you know where everything is linked in your sketches, you will you will feel just the pure satisfaction of having everything be completely updatable down the line. And when your boss tells you that you need to change something, and it takes you 5 minutes to change it because everything is completely updated automatically, you're gonna love it. So this is enclosure right. But actually it's not really how I want it, because I made the edges go all the way to the top, but I actually want to have a top plate. So I'm going to bring that down. And I'm going to draw a rectangle up here, which is going to represent the top plate. I'm going to delete that line because I don't need it, because this will be connected here. You like my map? Yeah, I need to figure out how to disable that in this stream. When I press G, it shows a map. The reason why is because sometimes I play a game called Rust, and in that game, when you press G, it shows where you are on the map in the game. But if you're live streaming, and you show people where you are on the map in the game, then that's a recipe for disaster. So you have like this fake map that overlays when you press the real map button. But I don't know how to turn it off. Maybe I can group and turn that off. Okay, I've turned it off. Now, I deleted my line up here on the top of this, which was constraining the thickness of the it was constraining the radius of the curve. So I'm going to add that. I'm going to add a line back in the center, so I can make those equal. And then I can use that line to constrain the top plate thickness. Actually, I'm going to make the top plate potentially thicker. No. Should I? See, I could make this 3mm. And like I said before, there's going to be these moments where I sit here and think, like, do I want to do it this way, where I'm linking this sketch to the enclosure top sketch, or do I want the side sketch to be the first one, and then the top one is linked to that, because that way I could set the top plate thickness and the bottom plate thickness in this one sketch, and then link the top to that. What to do? Well, what I should do is save. I'm going to save it to my PC. Because I don't want to get into a situation where, like, later down the line I decide to get the professional version of SolidWorks and then all of these files are saved in a cloud somewhere. So I'm going to keep them on my hard drive. I'm going to call it 0.1 LBM SK. You can't see any of this because I'm hiding it. But you can see now I've named this 0.1 LBM-SK. So 0.1 means it's version 0.1 and LDM for live drum machine -SK for skeleton. This is my skeleton model. Now I'm gonna try well, first of all, actually I want to figure out how to hide my dimensions. I'll quickly Google that. Hide constraints. Okay, that's easy. So this guy, Constraints. Relations, there we go. So it only shows me relations now when I'm actually clicking on an element. It'll show me the relations for that element. It's just a bit cleaner like this. You can see all the lines instead of being covered with all these green things. Okay, but what I'm going to do now is I'm going to try to swap the order of these. Oops, what just happened? What did I do? What is happening? Well, this is going to be probably the first of many technical hiccups. I like your map. That makes total sense. Yeah, because I explained the thing with the game, right? Yeah. It's just an OBS trick that I figured out. Okay, so this is working now. If I tried to drag this above here, it's not going to work because it says change would put child feature above its parent feature. What that means is that dimensions here are based on dimensions here. So this has the parent dimensions, and this has the child dimensions. And I think if I something I can do here to... Should have seen me yesterday with my technical issues. What happened? No, not mic problems. What is this? Like this document if you intend to save your changes to 3D experience. No. Yeah, here we go. So what I can do is turn on this dynamic reference visualization parent and visualization child. So when I hover over this sketch, you can see that it has parent links to the one above, and this one has child links to the one below. So I need to break those links if I want to move it. What I can do is go into this sketch, choose display, delete relations. I can choose external, so that's going to show me all the relations which are linked to things outside of this sketch. Some of them will be the links to the sketch that I want to delete them from, and some of them are going to be links to other sketches. But I'm just going to delete them all because I can relink them. So now this sketch is completely undefined, and that means I should be able to move it to here. Okay, and then I'm going to go in and redefine everything. So gonna link this to here, link this to here, and that to there. And the only thing that's missing is the material thickness. And like I was saying before, I was thinking I would define the material thickness for both the top and the side in this one sketch. So I'm moving the parent relation to here. Now, when I go back to this top sketch, it's also here. So I can delete this one, and I'm going to link this to this one. So all I have to do is make those two coincident, and now this sketch is now defined by the side sketch. It was just a rough stream. Sometimes my door and hardware stopped being friends. I had to restart my stuff a few times to get everything playing nice. I've had that a few times, man. I've had one day where I streamed 3 times in like 1 hour just because everything kept breaking. Just got to push through it and learn from it. Okay, so now, yeah, so now this sketch is driving the top sketch, and I can add here a note to say top plate thickness. Enclosure thickness. And that's just for my future reference, because when I look back at these sketches, I know that things that I've named are probably important. And also these labels show up in nice places, which I can show later. Alright, so I'm at the point now where I've probably made enough sketch stuff that I can start making some parts, because I can always come back. Lock required. I don't know what this means. Whatever, it's gonna save to the cloud. I'll learn as I go. So now I'm gonna show you how we make a part that's linked to the original skeleton model. So I've created the new part and I want to go insert part and whatever. I don't think I just want to check that I'm not gonna dox myself. No, it's okay. So yeah, it brings up this dialog of open documents. So I can choose that one. I don't want solid bodies. I just want absorbed sketches and unabsorbed sketches. Nothing else. If I have some fancy planes and stuff in there, I can bring those in as well. But right now, I don't. Using different measurement. Yeah, it always tells me this for some reason, but that's fine. So now I have a new part with the skeleton part inside it, and the sketches have come through, so I can reference everything in this part to the sketches in the skeleton part without changing the skeleton part. I'm going to save this also to my PC. Gonna call it enclosure 001. Okay. And I think I might have saved it, the first one, to the wrong folder. And now File Explorer is frozen. Whatever. Okay, I'm gonna make the top plate. So, what I might do I'm gonna add a little bit more to my skeleton model. So I've got my enclosure top. Something that I think is nice to do on sheet metal enclosures is when you fold the corners up, you can file a radius into the corners like this, which kind of gives you the appearance like it has curved corners. It is an extra step in the manufacturing though, but that's okay. That's the wrong thing. I'm doing this because this is going to be the shape of the top plate. I want the corners of the top plate to be curved, because having sharp corners on a device doesn't make sense, because they're going to look really not sharp. They'll either be sharp, which sucks because it hurts you, or they'll just be like jagged in the corners and not look very clean. So curved corners is going to be good. And I'm actually going to do another top sketch, and I'm going to call it like top plate or something. And this one is just going to have the shape, oops, of the top plate. And I'll show you why in a second. Yes, I know I could do fillets here, but I'm just in the habit of doing this with actual arcs because it makes life easier. Make these all equal. Gonna trim these. Oops. There we go. Oops, what's going on? Top plate. Okay. So now we can see my new top plate sketches in here. And what I'm going to do is in this part, I can hide all of these. I can even hide this actually. I can just click on this, press convert entities, and it's going to convert that over. So I have a top plate sketch which is reference to the actual top plate sketch in the skeleton. Call it top plate convert. Now I can put the enclosure right. Yeah, I can view it, and then I'm going to take this top plate convert and I'm going to extrude it. I'm going to extrude it from the vertex. This is the important point. Why I use SolidWorks instead of Fusion 360. Because as far as I know, and somebody told me that it could be possible, but nobody's ever showed me exactly how. But as far as I know, in Fusion 360, you have extrude from a surface or extrude from a plane, or you can just enter an amount, like an offset, and you can extrude in a direction blind. Like you can say, I just want to extrude 20 millimeters, 30 millimeters, whatever. Or you can go forever, or you can go up to a surface. That's as far as I know in Fusion 360 you can do. But what I really like about SolidWorks is I can offset from a vertex. So I can choose this point on my sketch, then I can extrude to a vertex and choose this point. So then my extrude is completely linked to that sketch, and I didn't need to make a top plane at the top of the device. I didn't need to make a plane at the bottom of the thickness or anything. I can link my extrude completely to the sketch just from the vertexes. And yeah, as far as I know, Fusion 360 doesn't have a extrude from vertex or extrude to vertex. And I think that those are like, that's the most critical thing. That's the one major reason why I'm not using Fusion 360. I think it'd be very easy for them to fix it too. Maybe they have fixed it. Somebody told me that it's possible, but when I looked in the extrude dialog, I couldn't find it. Now, I don't know what's going on here. This is a graphical error, but this happened to me yesterday as well. What is going on? Like, it should look like this with black lines on the edges. For some reason, it doesn't. Why is it transparent? I don't know. I'm gonna have to do it like this for now. I just can't see the edges, which is a bit annoying. Then I can set the material to be, yeah, I'll just make it 1060 alloy for now. It's an aluminium alloy. Then save it. Now, since I've got this set up where the skeleton's already imported, and I've got some extrude stuff happening, I'm just gonna save this as save a copy of this, and I can use that for my next part. So I go save as new, save to this PC. Whatever, I can show you this dialog. There's nothing here that's too... that's doxing myself. Yeah, so I've just changed this to 2, and I've clicked save as a copy and open. By default it says save as, but I want to make sure that it's making a new copy and it's going to open it. And I want to keep the original document open. So I have 1 and 2 here. Now, I'm going to delete this feature because this is going to be a different part. This is going to be the bottom enclosure. And I'm going to use hopefully if it's here, I'm going to use sheet metal features to make this. So first I'm going to get the enclosure top sketch, and I'm gonna make a big rectangle that fits the enclosure top. And that's going to be my base flange, I think. And the thickness is going to be 2 millimeters in the opposite direction. Now remember, I want everything to be linked, right? So I don't want to have to enter in 2 millimeters here and have that not be linked to the original 2 millimeters in the skeleton sketch. So I'm going to, I can't link it here, but what I can do is say, okay, well, let me just, as an example, I have to edit this. Let's say I made this 3 millimeters. So now I can go into, where is it? Tools, equations. And I have this dialog box here where I can find, here we go, dimension view. I can see the dimensions from the skeleton model. And I can see there that I have enclosure right 2 millimeters. This thickness, sheet metal, I want this to be equal to that 2 millimeters. So you can delete this, put in equals, click that, and click away. And now this is a constraint, like this is an equation, which is linking it back to the skeleton model, and that's making that value 2. So if I click OK, my thickness is now changed to be 2 millimeters. So now it's linked. So I can go back and change my skeleton model and this will update. Now I need to make some flanges. So first I want to do edge flanges here, 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 and here. This is going to be the tricky part, is how I get these corners to play nicely. As I said, I've been using this software for about 10 years, but the last time I used it was like 6 months ago or something, so I'm feeling a bit rusty. Okay, this is right. I want a custom relief type. Like a tear. Tear. I think first what I need to do, I can accept this and then I can change the sketches. Oh, I forgot how to do this. Want these to overlap each other. Okay, I think what I'm gonna do is I'll do these corners first. I can move that in. Okay. Now I want to bend these up. Yeah, that's better. That's actually allowing me to overlap them. Oops. Unable to create the edge flange. Why? Maybe it doesn't like this part. Okay, here's what I'm gonna do. Just as an experiment. I'm gonna cut some little holes in the corners. Okay. This is not gonna work. Okay, that works. It's very ugly. Oh, motherfucker. This graphical bug is annoying. Why doesn't it like it? Maybe I should actually check. This part intersects with itself after bend operations. No, it doesn't. It aligns with itself. Okay, I've got some problems to solve. I'm gonna bore the stream with this though. I'll figure it out off camera. Ding dong, ding dong. Still not working? Still not working. Whatever. I'll figure that out later. You get the idea. So now I've got an enclosure bottom. Hopefully it'll save. And I have my enclosure top. Here. I can hide that. And I don't know what this means, but whatever. So now I can finally make an assembly. So if I go new assembly, I'll also make this a white background. First thing I'll do is insert the sketch, which for now probably won't really be doing anything, but I can use that for aligning things later if I need to create mates or something. Then I'm going to insert components. I'm going to insert the enclosure top, change the view like that, and I'm going to insert the enclosure bottom. All right, and the enclosure top and the enclosure bottom are both yes, I need to name this, so I'll name it 0.1 let's go LBM dash dash A because it's going to be the full assembly. And save. So yeah, I don't know why I can't view this with lines, because normally I would look at it like that, but yeah, I have to look at it like this. And yeah, so you can see now if I go into this sketch, and will it let me, I should be able to edit this part here. Yeah, so if I decide, okay, I want the whole device to be 300 millimeters wide, press OK, and update, ding dong, that's just the sheet metal part failing, but you can see that it's updated the size. And here, if I decide that the top should also be 2 millimeters thick, I can edit my part again. I can go back to this sketch where I put in the top thickness, and I can make that 2 millimeters. And that has updated. So this is now 2 millimeters thick, but it's still meeting flush with the top of this because this part actually updated as well, because it knows that it has to reach the top point where this line is. Anyway, I've been going for almost 2 hours now. It's 9 o'clock and I haven't had dinner. And I'm having 2 very annoying problems here that I need to remember how to fix. So I think I'm going to call it. I'm going to put this back to 380, how it was. Did I do it? No. Yes, I did. Okay. There we go. Yeah, so I'm going to figure out why I can't see any lines here. And I'm going to figure out what's going on with the sheet metal, or I'll try and find a better way to do it. But yeah, right now, gonna call it. So as I said, very excited to be doing this, very excited to be working on music tech stuff, very excited to be doing design stuff. This is what I want my channels to be about. So yeah, if anybody had been checking out my previous streams or was editing photos and stuff, I might still do that occasionally, but it's not my primary focus. Like, this is what I want to be doing, and this is the thing that I think I'm best at and that I get the most enjoyment out of. The photo editing, I like having the photos, but you know, the result is the good part, but the process I'm not really that into. But with this, even in situations like this where things are annoying me, it's still you know, I love it. So looking forward to doing more. Hopefully some people become interested, and soon I'll have a session with the other guys. I'll get Yesa to hopefully join in, and he can give some background and some more explanation and stuff. We can talk about what other exciting things are going to be happening on this device. So thanks for watching. If you know anyone who would be interested in this, please forward them, bring them in. If you're interested in this kind of stuff and you're not already, it would be really cool if you could subscribe to my YouTube channel. You can find all of my socials here. If you're watching this on YouTube or wherever and it's possible to give it a like, then that would be appreciated. And yeah, other than that, just keep watching and join in next time. And yeah, any kind of viewership or likes or subscribers that I can get, it all helps just to get some exposure and stuff. But like I've been saying with the other streaming, I'm doing this because I like doing this and I want to do it anyway, as in the design stuff. I'm going to do it anyway, so I'm streaming it just to see if there is interest there. It is an extra level of complexity for me to do the streaming and to make the videos and stuff. So yeah, if people enjoy it and they like and follow and all that, it makes it worth it. So I don't know, let's see. If you can make that happen, if I can make that happen, that'd be great. Cool. Enjoy your evening or your morning or whatever, and I'll see you next time. Bye.